Hello everyone. Welcome to Mydbops MyWebinar edition 32 on the topic efficient MySQL indexing and what is new in MySQL Explain. My name is Shiny and I'm very happy to be your host for this insightful webinar. We are excited to have you join us today. About MyDBOps, founded in 2016, we have grown to a trusted database management and consultancy provider company with over 800 satisfied customers. We are proud to be an AWS partner and we are PCI and ISO certified, ensuring the highest security standards for your data. And our team of experts offers a comprehensive range of services to meet all your database needs, whether you need consulting or managed or remote DBA services. We specialize in a variety of open source database solutions, including MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra, and more. Today's session is all about optimizing your MySQL databases with efficient indexing and exploring the latest features in MySQL Explain. Our presenter for today is Jabushalomi Emmanuel from MyDBOps. She has extensive experience in database management and will be guiding us through the following topics: understanding the role of indexing in speeding up data retrieval, then different types of indexes and how to choose the right one, also strategies for optimizing indexing efficiency, and practical examples demonstrating the impact of indexing, and finally new features in MySQL Explain for better query analysis. We are confident that this session will equip you with valuable techniques to enhance your MySQL database performance. So sit back, relax, and get ready to learn. Without further ado, let's hand over to Jabushalomi to begin her presentation on efficient MySQL indexing and what is new in MySQL Explain.
Thanks for the detailed introduction, Shiny. Hi everyone, this is Jabasholomi Emmanuel. Today I'll be discussing on how we can improve the index efficiency with some examples and also some new features added in the innovation release in MySQL. If you're having any queries, please post it in the comment section. We will clarify all your doubts. About us, we are a database management and consultancy provider organization. We are founded in 2016 and we have assisted more than 800 plus happy customers. We are a AWS partner and PCI and ISO certified. Moving on to the agenda, in this webinar, we will see about index overview and also about the types of indexes and on tips of how we can increase the index efficiency with some examples and also some new features which was introduced in MySQL 8.1.0 and 8.3.0. Moving on to the index overview. So an index in a database is a data structure that improves the speed of data retrieval operations and processing time during data modification. So without an index, the MySQL will begin with the first row in the table and then it will read through the entire table to find the relevant row, which will be using higher cost. So an index will be created on the columns in from the table. Hence, choosing the right index is very important. It also requires regular maintenance to ensure optimal performance. To maintain them optimally, we can use table rebuild or we can analyze the table so that the index we have created will be maintained and its efficiency will also be up to date. So the most common types of indexes are primary index, unique index, composite index, and full text index. We'll see about each of them individually in the later sessions. So types of indexes. So this is a flowchart of some basic types of indexes. And they are ordered in their order of efficiency. So the first one, a high efficient index will be primary key, and primary key will offer the fastest retrieval for specific rows and enforces uniqueness. And unique key, it will guarantee that index key contains no duplicate values, and it will also allow null values. So this will be the main difference between primary key and unique key. And primary key is very important that all tables should have a primary key. So next is composite index. Composite index is useful for queries which have multiple columns within them, and we can, like, a single composite index can be created for all the important columns, so that it will be efficient instead of over indexing the queries. Next is covering index. So it in covering index, it will we can create multiple indexes as a covering for the query, from select for all the columns within the select, and also from the where condition. So this is called covering index. And full text index. Full text index is especially designed for all the index, for the columns with the data type text, varchar, and char. So only for these data type columns we can create full text index, which will be very efficient for all the textual data operations. And the last one is functional index. It is useful for optimizing queries which includes calculated columns like date of, and other respective functions. So these are some basic types of indexes which are most commonly used, and their functions. So increasing index efficiency. Now let's look on to how we can improve the index efficiency. So the first step will be analyzing the queries. So there are different types of queries. A query can have a subquery, or joins, or group by, order by, and multiple columns. It can be of any type. So we have to make sure that according to the query type, we have to analyze the query. We can either separate the query bit by bit so that it will be easy to understand. So we have to analyze the query, and then we can use explain plan tool also to help us in how the optimizer is going to analyze the query and give us the output. So we can also analyze the query by executing them, and so that we will get the time taken. And by getting the time taken, we can an idea of how we can further optimize the query and which one is taking more time. So for those columns, we can make sure that we are adding an index or any other further optimization. So the next important one will be avoid over indexing. So if there are 10 columns in a query which is getting included, so adding index in all the 10 columns is very it's not efficient way of providing efficiency. So in that case, the index will be, there will be, there can be duplicate indexes, or the index functionality will get decreased. So it is not recommended to create multiple indexes for a single column, as well multiple indexes in the table as well. We have to make sure that we are creating index only for the column which is very much important, so that if index is present in that column, the cost of the query execution and its time efficiency will be optimal. So next one is analyze the cardinality. So the word cardinality states like uniqueness. So in a column, if the cardinality is very high, it means that the index, the uniqueness of the column is very high. So if we are creating an index for the columns with high cardinality, it will be very much efficient. So we have to, while analyzing, we have to make sure that we are selecting an column which is having high cardinality, so that we will get an efficient output so that the index lookup will also be faster in the queries. Pick the correct columns. So, as we have discussed for the above points, picking the correct column is very much essential to avoid over indexing as well and other index related complications as well. To make sure that we are getting an optimal efficiency using an index, we have to make sure that we are picking the right column and we are checking the data type of the column as well. And after picking the right column, the next step will be picking the suitable index. So by analyzing the data type of the column, we have to make sure that we are picking the suitable index which will suit the data type of the column. And regular maintenance. Once index is created, we can't blindly believe that all the index will get used no matter of time. In that it won't require maintenance. But since tables get modified and the data will be stored, there will be many modifications happening in the tables regularly. Indexes also will require maintenance to check their efficiency. To check on the maintenance, we can make sure that we can do table rebuild, or we can analyze a table which will make sure that the data sets collected will get refreshed, and the index efficiency also can be checked once again later periodically. So these are some tips which will increase the index efficiency. So the next one is example. So for example, I have taken a full text column and a sample query. So we can see how we can make sure that we are choosing the correct index type and the correct column with from this example. So the column 1 is the uh, column we are going to take, and the data type of the column 1 is text. So this is a sample query and the table name is underscore function. So we are going to fetch the data flexibility from the table, and the total rows of this table is 96. So this is the overview of example. So you can see that we have analyzed the query, and we have also picked the right column. Since there is only one column over here, column 1, so we are picking the right column, and we have checked the data type of the column, which is text, and so that the correct index type will be full text index. So we have chosen all of this from the tips I have given. So now let's see the before optimization output. So we have run explain plan for this query. So in this you can see that the type, it's showing all. So it's going for a full table scan. There are in possible keys, it shows null, and key also is null. It means there are no index in this table currently for this column. So in extra, it's also using where. So it's not using the index and it's not optimized. So this is the overview of the before optimization result. And now let's see how we are going to optimize this. So since there is no index in column 1, we are going to create an index for column 1, which is full text index. So this is the query for full text index, alter table, table name, and add full text index. So index name and column name. So after adding, I have executed explain plan again, and in this you can see the type is same as all, and possible key, it's showing the index we have created, but in key it's showing null. It means it's not using the index we have created. So there is something wrong with this. We have created index but it's not using them. So let's see further on how we can modify and make the optimizer use this index. So let's see the after optimization. So this is the after optimization result. So what changes has been made to this query is that instead of just keeping as where, for full text index we have to make sure we are adding match for the column name and against for the data we are going to search. So if we are rewriting the query like this, it will the index will get used for full text index. This is specifically for full text index alone. So this is the condition to use match and against in the query. So in this you can see that index in type it's not all, it's for showing full text, means that the index is getting used, and in key also it shows the index we have created, and in extra also it shows ft hint sorted. So it is optimized, and index is also getting used. So this is how we can analyze and use, make sure that index is getting used efficiently. So now let's see the new features, like capturing explain format equal to JSON output, which was introduced in MySQL 8.1.0, and the variable explains underscore JSON underscore format underscore version, which was introduced in MySQL 8.3.0. So let's see about these new features uh, introduced in the innovative releases in MySQL in the upcoming slides. So the first feature is capturing explain format equal to JSON output. So capturing means in this feature, it is like storing the result of the explained format equal to JSON into a variable, and then if we select the variable, then we will be able to get the required result. So this is capturing. And in what cases it will be helpful for us is that if you are executing a query and you need to, like you don't have to copy paste the query again and again. Instead you can store it into a variable, and you can execute it, then execute the variable alone. So you, if the query is a long query, then it will be saving some like complicated, you will be able to easily understand the query like that. So it is helpful in that way. And so this is the format on how we have to use this. So explain format equal to JSON, and you have to use into, so that the output of the for JSON format will be storing into the variable. So we next is we have to give a variable name. We can give any kind of variable name, and then we can give the query. So this is the sample out query. So this will be the result. So after inserting the into the variable, if we select the variable, we will get the output of the query in JSON format. And this is only applicable for the explained format equal to JSON alone. Now let's see on the new variable introduced in MySQL 8.0, 8.3.0. So this variable is introduced in, and it like it we can choose like two versions of JSON format using this variable. So in default, by default in previous MySQL versions, like the version 1 is considered as default, and there is no version 2 we can choose. So from this release, we can choose a version 2 we're using this variable. So, and the main importance of version 2 is that it will show additional information on the optimizer's access paths. So by access path mean it will show some additional information on how the optimizer is going to execute the query. So some details will be additional in the explain version 2 format. So, and this one will ensure compatibility with the upcoming MySQL optimizer releases as well. So this will be incorporated into the further MySQL releases. and this one all supports the explain format equal to JSON outputs. So this is the overview of the variable, and this one is the validation of the variable. So if you are selecting the variable using this command, you can see that we are getting an output 1. So this is the default format of the variable version 1. So now in the next slide, you can see this for a sample query. uh, this is the version 1 output result of this query. So in the access type, we can see that it is all, and other related cost details and join details are present. So now let's see version 2. So we have to set the variable from version 1 to version 2. So this is a query to set it as 2. And for the same sample command, in version 2, this is the output. So you can see that there are some changes from the version 1 output. If you can see at the last access type, it shows filter, but previously it showed as all. So in version 2, the optimizer has provided some additional detailed information on how the query is getting executed. Now let's see the demo of all the examples we have seen so far. So the first example is going to be how we can create full text index, and how we can efficiently optimize the index using that, and how we can rewrite it. So let's check on it. So this is the test underscore function table we are going to use, and if you can see the data columns, we can see the data type is text for all the 4 columns we are using. And in the full text key, you can see that already IDX column 1 index is created for column 1. And so this is a sample command I'm going to use. So where match against column 3 and against the keyword shopping, and also match column 1 against the keyword flexibility. So if you can see in the show create table output, we can see that currently there are no indexes created for the column 3. So let's see if we execute it, what will happen. So I'm going to execute this query. So now I'm getting an error that we can't find the full text index. So if we are rewriting this query like this, so the columns which we are including must have a full text index when we are executing the query. Only then we will get the proper output. So now let's try to create a full text index. We are going to create a full text index on the column 3. So now I'm going to execute this. So the index is successfully created. So let's rerun the query we have executed previously. So here it shows possible key. It shows the column we have index 3 we have created just now, and it also shows the column 1. So optimizer is preferring to choose column 1 index over column 3, and efficient. It's the output is also efficient as it's scanning only one row. So this is the overall sample demo on using the full text index, and how we can rewrite the queries, and furthermore optimization using full text index. So there is also another feature we had talked about, like capturing explain JSON format into a variable. So now let's see how we can do that. Now let's see the demo on how we can capture the output from JSON format into a variable. So this is the sample query we are going to use. So I have used the variable var1, and when we are using the variable, we have to make sure that we are giving in at before the variable name. So this is sample query. Now I'll run it. So it shows query okay and 0 rows affected. So now let's test if we are able to get the output using when we are selecting the variable name. So this is how we have to select the variable name which we had inserted into. So I'll enter it now. So you can see that we have got the result from the variable name. So the table name is city from the database world, and we have selected between population, and the result is also matching. So this is the exact output from the query we had used earlier. So now let's move on to the demo of the explain format JSON version we can choose, the new variable introduced in MySQL 8.3.0. So I'm going to use the table city from the database world. So this is the show create table of the table city, and currently if you can see it, the version it's using is default version 1. So this is a sample query I'm going to test. So this works only for format equal to JSON when we are entering. So let's see how its output will be when in default version, that is version 1. So this is the default version. So let's move on to how we can check for version, how we can set it to version 2, and we can see how the result will be in version 2. So currently we have set it as version 2. We can validate it. So here it's showing as version 2. Now let's see the explain in JSON format for the version 2 as well. So compared to version 1 and version 2, there are various changes. So you can see access type is filter over here, and here it's as table. So it shows some detailed information on how the optimizer is choosing and executing its plans, and how it's accessing the data, and it's showing the result. So this is that's all for the demo. So in the past slides till now, we have seen on what are indexes and how we can use the indexes efficiently, and which indexes we can prefer based on the data types, and also uh, the new features which are introduced in the innovation releases, and which will be incorporated in future in the future releases as well. So, and with examples also we have seen. So by combining all these most of these techniques, and like all of them will be useful in query optimization, and the new feature releases like explain JSON format version, the variable, that's going to be a huge help for optimizer, and like for us as well to choose between the different version, as each version has significant difference in the data it's showing us. So debugging the query and optimizing will be very much efficient by using these variables. So I hope this information has given you insight on how we can optimize queries and use the indexes efficiently. So you can connect with us in LinkedIn and in YouTube as well. And if you are having any queries or any further support you require from us, you can reach us out info@mydbops.com as well. So thank you for listening to this webinar. And if you're having any queries, please share it in the comment box as well. Thank you.
Thank you, Jabashalomi, for your wonderful presentation. So, in this session, we just explore the power of indexing in MySQL for faster data retrieval, and we learned different types of indexes and strategies for optimizing their efficiency as well. I hope this webinar equipped you with valuable knowledge and actionable steps to enhance your database management strategies. Don't hesitate to revisit the recording for further reference. A big thank you to Jabushalomi for sharing her knowledge with us today. All your queries in the chat section have been addressed, and if you have any further questions or would like to continue the conversation further, feel free to reach out to us at info@mydbops.com. And please don't forget to send out a review of this webinar on LinkedIn, Twitter, Insta, and other social media platforms for supporting MyDBOps open source activities. Once again, on behalf of MyDBOps, thank you all for being a part of this insightful webinar. Have a great weekend. Thank you.